Hey, what's up guys? This video is for section 1.4, which is distributed property. And the first thing we're going to look at is what is the distributed property. So you guys see two examples here on the screen. I'm using variables, but it's the same idea when you guys have numbers with variables or just numbers. But the distributed property is when you have a term outside the parentheses and you are multiplying. Notice we don't have anything in between here. So you are multiplying times the quantity of what's inside of the parentheses. So I do have the a outside, the b plus c inside of the parentheses. So what we're going to do is you are going to multiply this term a times the first term inside, which is b. So I have this up here equals a times b. And then you multiply the same thing, a times the next term, which is c, a times c. I do have a plus in the middle, so I do keep the plus. So I have a times b plus a times c. If you guys are subtracting, and which like this one here, but you guys have a term outside, you are going to multiply a times the first one, so a times b, and a times the second one, a times c. Notice I don't have anything in between the variables, here, 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 or here, so we are multiplying. And there's a minus. So that's what we have to do when we distribute. Now you guys can say you multiply the terms, or we can use the actual word, you distribute the term outside. So you distribute the a times the first one, a times the second one. And what I like to show my students in class is, I just draw an arrow so they know what I'm multiplying. So the example on the bottom, I do have a number, 7, times the quantity of x minus 5, which is inside the parentheses. So once again, you don't have anything in between here, so you are multiplying. So we distribute the 7 to what's inside of the parentheses. So I go 7 times x, and you guys see here I have 7 times x, and I go again 7 times the next one. So 7 times 5 is right here, 7 times 5. I do keep the minus in the middle. So there's the minus, and when I multiply 7 times x, well, that's just 7x, and when you multiply 7 times 5 is 35. So the answer when you distribute the 7 to that parenthesis is 7x minus 35. Now sometimes when we use a distributed property, we are going to have what are called like terms. So you are able to combine like terms, if you guys have any. And that's what we have to do to simplify that expression, the algebraic expression. So here we have the definition of a like term. So those are terms with the same variable or variables, and the corresponding variables have the same exponent. That's very important, because you guys can have multiple x's in an expression, but not all the x's will have the same exponent. So I'm going to underline here, same exponent. So I have a list here to show you guys what are like terms, what are not like terms. It's just an example. So these two here are like terms because the x's have the same exponent. And if you remember, if you don't see an exponent next to the variable, it actually has an invisible one. So we do have an invisible one here and right here. So those two x's have the same exponent. Those are like terms. They have the same variables with the same exponents. The number in front of the variable, which is called the coefficient, remember the number in front of the variable, they don't really matter, but what really matters is the variable with the same exponent. Now these ones are not like terms because one has an x, one has a y. So you cannot add, you cannot combine those two terms. Over here we can combine, and we're going to practice that in a second. But I want you guys to identify what are like terms first. So these two are like terms. Notice the x's, x, x. The coefficients don't really matter. They can be negative, positive, but the variables are the same, and they have the same exponent, which is a squared for the x's. Those two x's have the same exponent. Over here, well, very similar, but this x, remember, you don't see an exponent there, but it has an invisible 1 exponent for the x, the variable, and the x over here has an exponent of 2. So those are not like terms. Over here, sometimes you can have a term, one term with two different variables. So notice here we don't have a plus or a minus. So this is called a monomial, only one term. And they have an x and a y. This here, it has a negative 2xy. Once again, no plus or minus in between, but we do have one term, same variables, x and y have the same exponent, which is an invisible 1. Over here, well, you guys have a negative xy, but this one has an xz, not the same. So these are not like terms. The last one, guys, this 2 is a monomial. In between the 7 and the x, there's no plus or minus. Here, in between the x and the y, there's no plus or minus. And we do have x, y to the third power. Remember the coefficient, the negative 7 here in front of the variable. Doesn't really matter. This is a 15, doesn't matter. But the variables and the exponents, they must be the same. So for the x, we have an invisible 1 here, invisible 1 exponent here. And for the y's, there's a 3, which is cubed, and y cubed over here. So x, y cubed, those are like terms. This one here, x squared y, negative 7, that's the coefficient, negative 7x squared y. And over here, 8xy squared. Notice the difference. X has a 2 exponent. This x has an invisible 1 exponent. This y has an invisible 1. Actually, let me write that down so you see the invisible 1 here for the y, and there's a 1 here for the x. So the y has a 1 here, and this y has an exponent of 2, which is a squared. So they're not the same because the x's don't have the same exponents, or the y's don't have the same exponents. Now, what happens when you guys actually have like terms? So one of the things that we can do in an expression is to simplify that expression by combining like terms. So combining is when you add or subtract like terms, and that's what we're going to do next. And before we actually look at combining like terms, one of the things that you also have to know is what is the standard form of an algebraic expression. So, and we need the standard form because when we have an answer, when we simplify the expression, we must have our answer in standard form. So what is the standard form? You guys notice all of this expression here. You have different variables. You guys have exponents, different numbers, leading coefficients or coefficients, and you guys have a constant. The number with no variable is called a constant. So every time you guys want the standard form of an algebraic expression, you always start with the highest exponent. That's the first one. So look at the exponents of the variables. There's a 4, a 3, a 2, and this one has 1, 1, 1. So the highest exponent is always first. And let me just underline that so you know that's the highest exponent. Highest exponent is first. And then you guys are going to descend on the exponents. So descending means you guys go down. So here you start with the 4. So the next one is 3, and the next one 2, and the next one 1, 1, and the last one is a constant. So you always start with the highest exponent. Sometimes you don't have an exponent of 4. The highest exponent is 3. So that's where you start, with the highest exponent of 3. Sometimes you have the highest exponent to be 7. So you start with the highest exponent 7, and then 6, 5, 4, 3, 2, 1, and the last one is a constant. Sometimes you don't have a constant. So like this one, you don't really need a constant for every algebraic expression. So you might be missing the constant, or you don't have one at all. Sometimes you might be missing the square, the x squared or the y squared, or whatever variable they use for the expression. So those terms can be missing. You don't need to have all the terms every time, but just make sure that you always have the highest exponent first, and then you guys descend on that. So now let's go ahead and look at how to combine like terms. So I have a few examples here. We want to simplify, and once again, let me just underline the word simplify the expression. So what that means, we want to combine like terms if we can, and we want to make that expression smaller. That's what it means. We want to do whatever we can, operations, PEMDAS, order operations, combining like terms. We are going to talk about the distributive property. So you want to simplify. You want to do whatever you can in order to make that expression smaller. So looking at the first one right here, and let me just zoom in here, we have 8m plus 10m minus 6. So minus 6m. So first of all, I want you guys to look at every coefficient, the number with the variable. This 8 has an m, this positive 10 has an m, and this one has the minus 6 and m. Every number has an m. So this is like saying, okay, I have 8 marshmallows, then I get 10 more plus 10 more marshmallows, but then I subtract 6 marshmallows. And marshmallows starts with an M, that's why I'm using that word, M. So you guys can say that, or you guys can say something else that starts with an M. So we have 8M plus 10M, 8 marshmallows plus 10 marshmallows minus 6 marshmallows. So you always want to follow the order of operation. So from left to right, we do have addition. That's the first thing. So let's go ahead and add. I'm going to add the 8 and the 10. So I'm going to have 18. And I'm going to keep that letter, the variable, m. So when you add, combine 8m plus 10m, that's going to be 18m. So 8 marshmallows plus 10 marshmallows equals 18 marshmallows. Now let me bring down the minus 6m. Now here, well, you guys have 18m. You guys added those two types of marshmallows, 8 and 10. Now you're going to subtract. You're going to take away 6 marshmallows. So 18 minus 6, that's going to be 12. And you guys keep the variable, 12m, or 12 marshmallows. Now make sense of the problem. We have 18m minus 6m. 18 minus 6 is 12. Keep the variable, and that is my answer. We have a monomial, one term, 12m. Now this one here, you guys have two different variables. We have an x, a y, and we have another x. So every time you guys want to combine like terms, just like the marshmallows, you need to add or subtract marshmallows with marshmallows, apples with apples, oranges with oranges, x's with x's, y's with the y's. If you guys have a different variable, t with the t. So you always want to combine the ones that have the same variable. Those are like terms. So I'm going to use different shapes to show you like terms. I'm going to use a square first. So this is a blue square for the 2x. And I do have another coefficient, the minus 2 with an x. So I'm going to use another box here to show you guys that those two are like terms. And notice what I did right now. This 2 is positive. We do have an invisible plus. Over here, we have a negative. So this is a minus 2x. So when you guys combine 2x minus 2x, or 2 minus 2, that's going to equal 0x. Now guys, when you guys have 0 amount, it's nothing. So actually, we don't need to put 0x. We know it equals just 0x. So let me just cross that one out so you guys know that we don't use that 0x. You don't have to write it down. But if you guys go back, we do have a y plus 9y. And around this expression right here, we don't have another coefficient with the y, another number with the y. So what that means is the 2x with the minus 2x cancels. It became 0x, but we don't need it. But we do bring down the positive 9y, which is the one we have left, and that is my answer. I don't have anything else to combine. So my answer is just this one, 9y. That one didn't cancel. Now here, well, you guys have the same variable, but pay attention to the exponents. This c variable has a square. This one has an invisible 1, and this one has an squared, an exponent of 2. Let me put the 1 here so you guys know that c has an exponent of 1. Well, you guys need to combine the ones that are like terms, the variables that have the same exponent. So I'm going to use another shape here. I'm going to use a bubble to show you guys what I'm going to combine. So this positive 5c squared, so it has a c with a squared, and the minus 7, yes, it is a negative, minus 7c squared. I'm going to combine those two bubbles. I have a 5c squared minus 7c squared. First of all, look at the 5, the coefficients, the 5 and the minus 7. 5 minus 7, that's going to be negative 2. You bring down the variable and the same exponents. Now careful with the exponent, guys, because common mistake, when students combine like terms, they like to add the exponents, 2 plus 2, and they put a 4 here. That's not what you do when you combine like terms. You keep the same variable with the same exponent. Now this one here, plus 3c to the first power, is not the same as c squared. This one has a square, this one has an exponent of 1. So I'm going to bring down the plus 3c. I'm not going to put the 1, but it is an invisible 1. And guess what, guys? These two you cannot, you cannot combine, add, or subtract the numbers, the coefficients, because they're not like terms. The c has a square, and this c has a 1. So that's my answer. But let's check. Is it standard form? I'm going to look at the exponents, and 2 is the highest exponent in this expression. There's a 1, but the highest exponent is 2. So that is my standard form. So my answer is negative 2c squared plus 3c. And this one here, same idea, same concept. You want to combine like terms. You want to simplify the expression. You want to make it shorter. So standard form, we want the highest exponent first. So let's go ahead and look at the highest exponent. I'm going to check, understand the problem. X cubed, this one has an x to the first power, invisible 1. 7, this is a constant, doesn't have a variable. I see an x cubed over here. I see x exponent of 1, and I see another constant. So the highest exponent is 3 here. So I am going to combine, and I'm going to use a triangle here, so you guys know I'm just using a different shape. I'm going to combine that triangle, 8x cubed, and this is to give you guys a visual what I'm combining. And this one over here is a like term, negative 5x cubed. So remember, you guys need to combine the two coefficients, the numbers in front of the variables. So we have 8 minus 5, that's going to be 3. Bring down the x with the same exponent. Do not add the exponents. So right now look at the triangles. 3, 3, there's a 3, keep the variable, and 8 minus 5 is positive 3. Now I go to the next lower exponent. Now after 3 cubed, 3, we're supposed to have a 2. But you guys notice that we don't have an exponent of 2. That's okay. You just go to the next lowest one. So the next lowest one is 1. 3, 2, and then 1. So we do have 1. So here I have this one. I'm going to use the circle, orange circle, negative 3x plus 3x. Well, negative 3 plus 3, 0. So those two terms cancel. We don't need to put the plus 0 there, minus 0, 0 is neutral, but we don't need it. They just cancel. But I do have a constant right here, plus 7, and the minus 10. So you guys combine those two constants, positive 7 minus 10, that's negative 3. So my answer starts with the highest exponent, and that's the only exponent we have here for dx. So that's the highest one. And you guys descend until you guys have the constant at the end. So my answer is this one, 3x cubed minus 3. Now notice what happened with the expression. We had a long expression up here, and we made it shorter. So that's simplifying. You guys want to combine like terms. You guys maybe have to distribute. We'll talk about that in a little bit. Maybe you guys have to use order operation, but that is simplifying. In this one here, you guys have a 3a squared plus 5b minus 5 minus a. So first of all, look at the variables a squared, b, and a. Well, this one has an a squared. I'm going to look at the other a. Well, guess what? That one is exponent of 1. Okay, so they don't have the same exponent. This one's a square, that's a 1. You cannot combine the two terms. And just in case you guys forget, this a at the end right here, we actually have an invisible 1 here. So we have a minus 1a to the first power. The one in the middle, it's a b. So it's not the actual a letter, the variable a. So these a's are not like terms. B, there's no other b that you guys can combine because it's not a like term. So when this happens, guys, you cannot combine any of those terms. We say it's already simplified. So you guys write the word simplified. Simplify right here. So that's what we say. You don't have an actual expression. That is your answer. It is simplified because it's already simplified. You guys cannot combine any other terms. All right, guys, I'm going to have to do a second part for this section, which is the distributive property. The next video, the second video, it will talk about that property, the distributive property. Right now, we just talked about combining like terms, but I needed to talk about this because when you distribute, you can combine like terms. Not all the times, but sometimes you can. So make sure you guys check that video out. And if you guys like my videos, you guys can hit that like button. And if you haven't subscribed to my channel, you guys can do that as well. And make sure you guys practice, and I'll see you guys later.